Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on exercise 8E, which is on integrating vectors. So I'm given the acceleration, and I'm asked to find the velocity. So there's no reference in the question as to whether I should be integrating or differentiating, so I need to make sure I know which way around it all goes. And velocity is going to be the integral of acceleration. Okay, so that's the vector they gave me for acceleration. I'm going to integrate that with respect to t. Okay, so the I component is going to integrate, so I'm going to increase that power to 3, and then I'm going to divide by 3, and then there will also be a constant. So I'm going to put plus C1 there, okay? So then when I integrate my J coefficient, the 8 is going to integrate to 8t. That power is going to increase to 4, so when I divide by 4, the coefficient will just cancel to 1. And then I will have another constant of integration. Now, in the textbook, they do lay it out slightly differently, and you can just go for your preferred method. So in the textbook, they just have a plus d on the end. So you should have already read through those examples. It's however you prefer to lay it out is absolutely fine. Okay, so find the velocity when t is 2. So if I read back through the question, it says a particle starts from rest. So that is how I am going to find those two constants, or that constant vector. So if it starts at rest, when t is 0, v is 0. So 0 is 2 times 0 cubed plus, sorry, I should say I, not c. Okay, and then same, if I look at this vector, if I sub 0 into that, I just get the constant. So c1 and c2 are both 0. So my full velocity vector is just 2t cubed I plus 8t minus t to the 4j. Now just be careful, because even if you can look at the question, you realise that the constants will both be 0, you do still need to refer to them. Okay, so you do still need to show that when you integrate, and it's not definite integration, you're going to get a constant of integration. Okay, but now we have shown that, quite straightforward. So when t is 2, the velocity, so if t is 2, that is going to be, so 2 cubed is 8, times 2 is 16, and the j component, so it's going to be 16 minus 16. Okay, so j component is 0, so 16i meters per second. Let's just check that. Yeah, we're good. Okay, and then find the position vector. So position vector is going to be the integral of velocity. So it's going to be the integral of, so there's my, oh, I can't see my screen. Right, okay. So position vector is going to be the integral of velocity, and that's my velocity vector. So the position vector is going to be the integral of 2t cubed I plus 8t minus t to the 4j integrated with respect to t. Just to show you the slight alternative, I'll lay this one out as they do in the textbook. It's probably a bit easier if I'm consistent. So I'm just going to integrate each of the vectors and then do a single constant on the end. So 2t cubed, so I'm going to increase that power to 4, and then 2 over 4, so that'll be a half t to the power of 4i. And then 8t is going to integrate to 8t squared divided by 2, so 4t squared, and t to the 4 is going to integrate to t to the 5 over 5. Okay, and then plus a constant. So I can just have the constant separately, okay? But that constant could potentially, that's going to be a vector, and it could potentially have an I and a j component, okay? So if we look back, they also tell me here that it starts from rest at a fixed origin. So it's starting at the origin. So when t is 0, position is 0. So again, if I just confirm that, it might be quite obvious that d is going to work out to be 0. I'm trying to start PowerPoint. But again, just make sure you're actually showing it. So if t is 0, that's 0, that's all 0. So if t is 0, when r is 0, d is 0. Okay, so that's just an alternative. So if I do it this way, d is potentially going to be a vector, whereas the way I did it for part A, those two values of c would just have been constants to find. Okay, so, but either way it's 0. So my full vector for r is t to the 4 over 2, my I component, 4t squared minus t to the 5 over 5 for my j component. Find the position vector when t is 4. So when t is 4, r is 4 to the power of 4 divided by 2. So 128i, and 4 times t squared minus t to the power of 5 over 5. So I'm going to check I've typed that incorrectly, but I'm getting that to be minus 704 over 5. And yep, doesn't ask for anything else. Let's just double check. Is that the same? Yep, so we are good. Okay, so 704 over 5 is the same as 140.8.